Okay, good afternoon, everyone. Welcome to this lecture. In this lecture, we discuss the service-oriented architecture. In the last three classes, also we have seen various topics of the service-oriented architecture. Like we discussed what is a service, what is a web service, what is a service-oriented architecture, and how messages are communicated from one component to another component, which we have seen in the form of middleware. Then in the last class we discussed about various portals and service gateways. I gave you a lot of the many illustrations of various service gateways used by many reputed research institutes. In today's lecture, we discuss about four things. One is the service discovery, another is the registry, next is your metadata, fourth one is your database. Right? In web service perspective, we are going to see how these things are used in the service-oriented architecture. So when you go for distributed applications, they need to discover resources that's full their needs and manage them. You go for any distributed applications, okay, like we discussed about various real life applications like climate prediction.net, or you can go for weather forecasting, or you will go for DNA or RNA analysis, or you can go for Milkway at home. A lot many projects are there. So first objective is whenever you want some service, the very first step is coming how to discover a proper resource for your service, right? Like in Amazon S3 also you have seen you have created a particular bucket. So now the question comes, if you want to create a bucket, you have a requirement. There is you mentioned your requirement, but that is not that much customizable because they have already defined something. We are using that. But when you go for the subscription based, in the subscription based what happens, you may go for a little bit more flexibility. So in that, what you are doing whenever you want to create a bucket, you have to see where to the resources, whatever required for bucket, where we are going to get that resources. For that, discovery of the resources is required. Or you go for a simple YouTube examples also. Suppose you want to learn cloud computing regarding service-oriented architecture. So what you are doing? You are typing a particular keyword. Based upon your keyword, the search is going to be performed, and whatever results are generated, that will be given to you. Right? That results are will be given to you. So, if you see the resources, whatever available in YouTube, they are also deployed in some data center, or they are also stored in some server, right? So this mapping of a particular service with the resources is very much important. Okay. So how you are going to locate the service with resource? For that you need discover of the service. You have to discover the services and you have to locate the services in order to deploy your application. So in service-oriented architecture, if you see, business services need to discover appropriate services to use and to integrate with. Sometimes we require composite service. Whenever you go for the composite service, one service is integrating with another service to provide the work. Like you know that some cloud service provider is providing IaaS, some cloud service provider is providing SAS, somebody is providing platform as a service. So if you see that, suppose I need to deploy an application which requires three types of services, both IaaS, PaaS, and SaaS. All the three things required: IaaS, PaaS, and SaaS. And I don't want to take this IaaS, PaaS, SaaS from a single cloud service provider. What I will do? I will take multiple cloud service providers to fulfill my requirements or to deploy my applications. There, integration plays an important role, right? So this is all about our discovery, the definition of the discovery, right? Irrespective of the application, generally in the business services, as cloud is focusing on a business model, so we are saying integration is an important part. The second part. The second part is the registries. So registries are sophisticated naming and directory services that facilitate service resource discovery both at its design and dynamically at runtime by classifying and categorizing the services or metadata information about the services. So if you are stored, come to our computer example. In computer also we have various drives. In each and every drive we have a set of folder. In each and every folder you have a set of subfolder. In the subfolder you have a lot of files. So how to access a particular file? You have to maintain a directory, or you have to give a specific name. By using that name, you can search a particular file. So for that, what you need? You need the registry. Because registry is going to provide a specific name or the directory of the resources by which you can search for a particular resource. Right? And registry requires a set of data structure. How to maintain this registry? Which folder is under which folder is there in read drive, which folder is there in drive, where my image file is there, where my audio file is there, where my video file is there. For that you need a data structure. Okay, if you maintain a proper data structure, accessing the data is very easy. You studied in data structure how faster we can access the data. It depends upon the data structure. So registry also uses this data structure specification for metadata. Try to understand data and metadata, they are different. Data, whatever content you have in each and every individual file, that can be called as data. But while we are talking about the metadata, in metadata you will see you are looking into various properties, characteristics, features of various services or various files or various directories. Right? I'll tell you a small illustration in the later part, like how metadata is maintained. Like if you consider a movie case, we have a lot of movies, but these movies can be classified by introducing a feature that is type of the movie. One movie may be a drama type movie, another may be a horror type movie, another may be a crime type movie. Different movies are there. So if I maintain the metadata of all the movies in which type is an attribute, type of movie is an attribute, then you can easily assess. For example, you are interested in the crime type movie. So the movie whose metadata attribute, okay, the type attribute is equal to the crime, then that movie will be only be extracted. Other movies you are not interested for, so that movie is not going to be recommended to you. Okay. And here also you can see a set of operations you can perform in the registry. What are the operations you can do? That is nothing but our CRUB. CRUB stands for create, read, update, and delete. You can create a registry, you can read a directory, sometimes you can update the directory based upon the information, and you can also delete the directory. Right? So these are the four things you can apply into the metadata. Okay, to store the metadata or in the registry, you can apply this set of operations. Okay, to store metadata for ownership, containment, and categorization of the services. Because all the services you cannot be represented in a single folder. You imagine in a computer, all the files you will be keeping in a single folder. So it is very difficult to locate the service, right? That's why you need multiple directories, multiple files, multiple web service, and they should be maintained in a order so that you can access the required data or whatever service you are searching in a faster way. So that is the objective of registry. And obviously, the fourth term, that is database, whatever you have studied in SQL, okay, structured query language or Oracle 9i, Oracle 10i, what things they are, how these things they are maintaining, whether they are integrating with discovery and registries, whatever required, that we are going to see in the databases. So very simple example you can see, there is a service provider, let it be a cloud service provider, right? And there is a service consumer, that is our nothing but a client or a user or a end user. So service provider publish the web services in the service registry. Okay, so it is introducing various services or it is maintaining the services in the form of a service registry. Okay, like you can say in the our Amazon case, we are maintaining T2 micro instances or T2 large instances or T2 X large instances. These are maintained in the service registry. Then how a customer will identify these things? So they need to discover the services as per their requirement. Suppose whatever the requirement mentioned in the large file, that is sufficient for me. Okay, so what I'll do, I want to subscribe this discovered services, right? So I have discovered and found that this service is sufficient for my application. Then what I'll do, I want to invoke that service from the service provider, right? Just like you consider the concept of our library also is same as that library. A particular institute or a librarian, what they are doing, they are putting the books in the library, right? In a particular order, right? Let's say CAC is belongs to rec 1, electronics is belongs to rec 2, something like that. What we are doing, we are searching for a particular book. Once we are getting a particular book, what we are doing, we are invoking that book, we are issuing that book. So that is nothing but that service is going to be provided by the service provider once the request is reached to the service provider. The idea of maintaining service registry is that service provider can publish a particular thing and service consumer can discover a particular thing. So that the request response things can be done in between the service consumer and service provider. So if you go to the registries, the registry contains three categories. So they represent in the form of three colors, that is white, yellow and green page. They call it white page, yellow page, green page. Like you know the company also in any organization, if you go, the organization has a hierarchy. If you consider our NITW also, there is a hierarchy. Director has given supreme power. Next to director, deans are there. Okay, or the registrar is there in parallel with the director. Okay, then deans are there, other departments are there, faculty members are there, students are there, visiting faculties are there. There is a proper hierarchy. So each and every hierarchy or each and every level in the hierarchy, if you see, they are given with a set of responsibilities. And what they can do, what they cannot do, they are aware of it. So it is not possible for a student to retrieve all the details from a particular institute. However, if you consider in the case of dean level, they can extract the information. So in one level, the information, the full information may not be provided. But another level, the full information may be provided. Another level, partial information may be provided. So in order to distinguish this, these are the different pages maintained. Where white pages contains your name and general contact information about any entity. It is only contained two things, name and general information. Right? We don't want to show you the internal details. But if yellow pages is there, yellow page contains classification information about the types and locations of the services, the entry offers. Right? So you are able to know what are the different types of services are there and where these services are located or which resource is going to provide you this service. That is the yellow page. Third one is your green page. Green page contain information about the details of how to invoke the offered services. Okay, how you can assess a particular services through a request response thing that can be done in the green page. So that is nothing but the technical data regarding the services you can see in the form of in the green page, right? So these are the three registries they are maintaining. The idea is to not to propagate all the information in all the levels. Okay. One thing, if you see in the positive side, you can say all the informations are not required to each and every person. Like as a client, I may not understand what is a data center, what is the temperature, cooling temperature in the data center. I may not be interested to know. And in the negative sides, if you provide such information, a client may not interest to get a particular service. If you show your internal details, what is the cooling temperature and how many staffs are working, what is their cost, everything, then nobody will be interested in the service. That's why we are maintaining the information in the form of various pages. So one of the very popular directory, okay, you can see here, that is called as UDDI. You may heard this term because previously also I introduced this UDDI. UDDI stands for Universal Description, Discovery and Integration Specification. As the name suggests, and also I mentioned the information of white page. White page saying the general information or the name, right? So UDDI is saying it is providing the description of services, or it is also it is also providing the discovery of services, and it is also helps us to integrate one service with another service. So UDDI is based upon our XML based standard. Most of the things, whatever you are seeing in the service oriented architecture, that is based upon our XML. And UDDI also defined a way to describe, publish, discover information about web services by creating a platform independent and open framework. So you can publish as a service provider, you can publish a service. As a service consumer, you can discover the service. And you can get the description of the services by using UDDI. So this UDDI, okay, was initiated in the September 2000, right? As a joint collaboration on B2B integration. B2B integration means business to business integration. One business is your IBM, and you can consider one company IBM. Another business may be happening between Microsoft. IBM and Microsoft collaboratively providing some services. Okay, so in order to integrate two different business, one may be IBM, another may be Microsoft, another may be Arima, right? So any two you can pick. They need some collaboration, so there is a integration is required. Business to business integration required, where your UDDI is going to help you, right? So UDDI has so many versions. One of the versions you can see here, UDDI version 3.0, which is published under OASIS specification, just like our ISO standard and other standards are there, right? ISI mark is there, hallmark is there, right? So this is published under OASIS specification. And if you see, based upon the common set of industry standards, industries, if you see, they are using HTTP or HTTPS, they are using XML. Most of the services is providing using XML or XML schema, or they are using the simple object access protocol instead of the RESTful API. Okay, so UDDI provides an interoperable foundational infrastructure for a web service based software environment. Okay, so this environment, whatever UDDI is providing, so it may be publicly available, like many services are there that is available publicly. Anybody can access that service, and anybody can discover the service, or if it is limited to a particular organization, the service is exposed internally within the organization. Like one information is there that can be shared in NITW only. So this should be, services should be available internally. It should not be outside our NITW boundary. Such type of discovery can be provided by our UDDI. So UDDI consists of two primary types of registries. One type is called as a public registry, another is called as a private or semi-private or shared registry. Right? Which one is shared within a single organization. But whenever you go for public registry is a logically centralized. It is logically centralized, but if you see physically it is a distributed service. For example, I told you in the single system image also, you are interacting with your computer system. Like you are interacting with your class representative. Okay. So class representative is a single point of contact. Or the system to which you are submitting your application, that is a single point of contact. So in your perspective, you can see it is centralized. But Whenever you see the scenario, once the information is given to that computer system, that your work is now divided and it is given to various units. Like if I will inform something to the class representative, the class representative is giving the information to each and every individual student and they can work in a particular assignment. That's why it is saying it is physically, if you see, it is distributed services. Okay. So you may go for the replications also. You can go for replicating the data with other public registries on a regular basis if you are going to public registry. A UTDI registry is an instance of a web service and its entries can be published and queried using SOAP based interface. SOAP is nothing but your simple object access protocol based interface UTDI is using in order to publish or query anything. Okay. So UTDI defines the data structures and APIs for programmatically publishing service descriptions and querying the registry. Right. So in three things you can remember. One is your description part, another is your discovery part, third one is your integration. These three things can be done by the help of UTDI. So what are the things? What are the instances you can say? How UTDI is managing these things? So the data in the UTDI registry is organized as the instance types. So there are a lot of instances are there in the UTDI. The first one is called as a business entity. So business entity means it is describing an organization, okay, or business that provides the web services, including the company name and company's basic information to whom we have to contact or what is the contact information, what kind of services it is providing. That is the responsibility of business entity. You can say it is a component. I will tell you in the form of a diagram later. Now the theory part is over. Next one is a business service. Business service focuses on a collection of related instances of web services offered by a particular company or an organization or a business. Okay, such as name of the service and each and every service description you need to mention in the business service. Third one is binding template. Like I told you about VM template. So whenever or in Amazon S3 also while you are creating Bucket, what you are doing? You are taking existing template. So this binding template describes the technical information necessary to use a particular web service, such as URL address to access the web service instances or references to its descriptions. So that is the responsibility of binding template. Another three things is one is T model. T model is a generic container for specification of WSDL documents in general web services. Publisher assertion is establishing the relationship between two business entity. Subscription is nothing but a standing request to keep track of the changes to the entities in the subscription. Okay, so these are the six instance types makes the UDDI to provide the discovery of the services and the integration of the services and description of the services. Okay. And if you see these, each and every individual component is assessed using URI, that is Uniform Resource Identifier, just like our URL, or we can say it is a UDDI key. By using UDDI key, you can access each and every instance provided by UDDI registry. So let us see the example so that the idea is more clear. See here. There is a business entity here, one business entity is here, another business entity is here. We discussed 6 points, right? 1, 2, 3, 6, up to 6 points, right? So the very first one I told you the business entity. What business entity is expecting? It is expecting that human readable information about the service publisher. Whatever things you are mentioning here, that should be easily readable to the client. That is the responsibility of business entity. Okay, and two business entity can be combined. Okay, if you want to provide services of using both the business entities, they can be combined using publisher assertion, which establish the relationship between two different parties. Okay, you can see this is a different service. This part is completely different than the previous one, right? And one business entity can have multiple business services. So what business service is doing? Business service is providing name to the service. It is providing the description of the services, right? So you can see in the first business entity we have two business service. In the second one we have a single business service. Under the business service, you have a lot of templates. That is called as binding template. Template is going to provide you the information around the service interface. Okay, template is providing you the URL address as well. So once you get this URL, what you can do? You can access to this generic container, okay, for specification of the WSDL documents. Right? So main thing is you have to access T model. So in order to access the T model, you have to get the template from binding template, which is under the business services, and multiple business services are provided with a business entity, and multiple business entity can be combined by using a publisher process. Right? So this is called your UBDI and the relationship between the different instance types of UBDI. So there are 6 basic types are there, right? The 6 basic types you can see. The first type is, suppose you want to inquire about a particular API. Just you want to know that we want to find the registry entries, right? Such as business or binding or TO. So what command you have to use? You have to use find or you have to use get. So first operation is nothing but you are inquiring for some service. That can be done by the help of find or get. Second one is UDDI publisher API. What publisher API is giving? Publisher API you can enable this API enables add, modify, delete entries by providing save or delete. If you write save followed by something or delete followed by something, it will update it or it will delete it. That is the responsibility of publisher API. There is another API that is based upon the security. So you know that whenever you are establishing a relationship between two different components, so they having a common key, or they have a common token, or they have a session. So that session needs to be secure. So in order to get such a token or session, you can request get underscore AUT authentication token, or in order to discard this, okay, before suppose your service is done. So after that you want to close the session, you can use discard underscore authentication token, right? Fourth part is your UDDI custody and ownership transfer API. Here what you can do, this API enables the registries to transfer the custody of information among themselves. Suppose I have decided you are under registry X, I want to switch to registry Y, just like our migration. So what you are doing? You are transferring the custody of your information from one registry to another registry. So there you can use this transfer underscore entities, or you can use transfer underscore custody. The next basic of API operation is the subscription API. So if you want to subscribe a particular event or a service, you can use get subscription. Okay. Then if you want to search for a particular or you discover a particular service, you can get the subscription results. You want to delete a subscription, you can use delete underscore subscription. If you want to save your subscription, okay, then you can use save underscore subscription. The last operation is your replication API. So replication API supports replication of information between the registries. Why you need information between the registries? Because all the registries may not be capable to hold all the information. You need a set of brokers. Last class we discussed, you need a set of brokers, like that you need a set of registries. So that if in the fault tolerance perspective also it is better. If you are taking the replica, if something is failed, you can reply from the other. That is also advantages of doing for multiple registries. And these registries need to be synchronized. If registries need to be not synchronized, then what happens? Inconsistency may arise. So UTDI is a open standard, but it is not gained that much popularity because it do not have a global registry. Each and every registry in UTDI is a local registry only, it is not a global registry. And one of the public registry, just I want to give a demo here, that is called as programmableweb.com. So you please visit programmable.web.com. Okay, this website you can visit programmableweb.com. So this is a public registry. So what type of things is available in this program web? You can go to its API directory. If you click API directory, you can see what are the different APIs available. Facebook API is there, Yahoo Weather API is there, Google Map is there, Yahoo Weather is there, Weather Channel is there, Wikipedia, OpenStreetMap, Instagram, all of the APIs are available. Okay, you can also extract, like I want to extract the tweets which is which I made, okay, in the Twitter, or what are the tweets is there in my profile, I want to extract. So for this also Twitter API is there. So this program where is providing a lot of APIs, okay, which you can access. For example, I want to, let's say, Google Map API. So you can get your Google Map API here, right? And the versions of the Google Map API is also you can get. There are a lot of versions are there, right? So you can go to this one, you can download it and you can use it, this particular API. Okay. Now, this is about the programmable web. Let us discuss the more about the programmable web. So programmableweb.com is a registry of a variety of Web 2.0 applications. I told you, in order to access the cloud services, what you need Web 2.0. As per my knowledge, Web 3.0 is also launched, right? So this Web 2.0, a variety of Web 2.0, such as you can say mashup or APIs organized by category or date and popularity, you can get from programmable web platform. And they are also providing various APIs with respect to what? With respect to the mapping, with respect to the search like Google search, with respect to the travel, with respect to the social information like Facebook, instant messaging, software, video streaming. These all things are provided in the programmable web platform. Right? So these APIs you can use, right? And if you see what are the standards used in this programmable.com, they are using XML-based standards, RSS, OpenSearch, pattern publishing protocols. They are using in these standards are using in the programmable.com. Okay. So next is the most popular method, like we've already seen, that is Google Map, Twitter, Facebook, Instagram, Twitter, YouTube, all are using such a registry. Okay, such registry they are using, and this registry is also supporting the Web 2.0 application. That is a composite Web 2.0 application is also provided so that you can apply your services. Now, if you go for a high level applications, go for a big applications. In the big applications, if you are maintaining a database or if you are maintaining the data in multiple locations, what will happen? Periodically you have to go for data pooling. Why data pooling is required? In order to make all the things synchronized. Like you are doing some work in your computer system, you have modified it. You have the same Google Drive account in your mobile. So then it is so periodically the data pooling is happening. So if you go for such periodic data pooling, is not only inefficient but it is unscalable. But resource demanding on both sides, especially when the interval between the calls to the database is very small, and in cases when there is more than one consumer application, it may increase the amount of network traffic and CPU usage. Okay. So periodically, if you do this one, it will increase the traffic also because repeatedly you want to make it update in each and every position. So in order to solve this, what we are doing, you are using public subscript mechanism. Okay, it is largely adapted in the implementation of various applications which is available today and which solves the issues of periodic data What PubSub model is doing? A publisher is publishing the event and subscriber is subscribing the events which he or she is interested for. That's why the subscriber registered to the particular event types, not all the event types. So you need not do the data pooling in each and every type. Okay, and subscriber receives a notification whenever a publisher is going to update something or publisher is posting something, then only the subscriber is going to get a notification. But if you see this publisher subscriber model, early days it is purely a centralized system, but now it is a distributed system. Although it is client server system, but now it is completely a distributed system where what they are doing, the publisher and subscriber interaction, they are performing, right? So you can say the client interface of the public subscriber system is very simple by the help of this PubSub model in comparison to the high level application whenever we are considering these databases where the database is replicated in various places. So these publisher subscriber systems are classified into two types. One is called as your topic based, another is called as your content based. Topic based means like I want to subscribe cloud computing. My topic is fixed, right? So in topic based system, publisher generate events with respect to a topic or a subject. And each and every index event is indexed based upon the topic and subject. So subscriber then specify their interest in a particular topic and receive all events published on that topic. So is a subscriber, if I am interested in X topic, I am going to receive the events with respect to that topic. On the other hand, if you go for the content based system, it is introducing a subscription scheme based upon the content of events. We are not going for a particular topic, we are going for the content of the topic. So if you see the content based system, okay, here you can see how they are going to give the content based systems are preferable as they give users the ability to express their interest by specifying the predicates over the values of a number of well-defined attributes. Okay, you specify what are the content you are interested for. Based upon that, they are going to provide the suggestion. Right? Now, if you see the database system, now we compare how database system is integrated with this PubSub model. That's why the database system provide many features we have seen in the DBMS, right? Message-based architecture can exploit such as reliable storage, transactions, triggers. These things are provided by the database system. So if you can integrate these publish subscribe capabilities in the database account for information sharing system that are simpler to deploy and maintain. That's why you can go for database publish subscribe aware system. One of the popular example where the database system or database technology is integrated with publish subscribe model is called the post GRE SQL. Let us explore what is this one. This post GRE SQL allows a database system in the local domain to function as an event broker. So with respect to the zone or with respect to the domain, one database system is there. The database system is the local database system. So this local database system is nothing but an event broker. Okay, they can act like a event broker. And they, as a broker, what they can do? They can do the routing events. They can publish a event, they can subscribe the event as per the requirement of a particular user. Okay, reliably routing events among publisher, subscriber, and other brokers. They can coordinate with other database system in order to publish or subscribe or in order to extend the messages. Okay, so this integration is very much important. Integration between the database and publish subscriber system. So it also simplifies the information management by grouping security, configuration, and recovery the task from the database and PubSub operations under the same interface. Okay. Now let us see this Oracle PubSub model. You can see here the applications are there, where one application may be published by one party, another party want to subscribe it, just like our YouTube, right? I am publishing my lectures, okay? You are watching that lecture, right? So it may be a publish. It may happen that one publisher is also a subscriber. As a publisher, I am also subscriber to other events, right? So message queuing and publish subscribers are tightly intertwined. And Oracle introduced a publish subscriber solution for enterprise information delivery and messaging. So you can see here, Oracle is performed that. And if you go for Oracle, the advanced queuing is introduced in the Oracle version 8, right? Advanced queuing was introduced in Oracle 8. Later, it is extended, means its extended version, that is Oracle 9.8, is supporting in a public PubSub model. Okay, and in Oracle release 10.1, there is a advanced queuing, that is OSAQ, Oracle Stream Advanced Queuing. Okay, which is nothing but integration of this advanced queuing, which is there in the Oracle 8 and Oracle 9i, is integrated into Oracle Stream. That's why it is called Oracle Streams Advanced Queuing is incorporated in Oracle 10.1. So if you see this one, here what happened, the advanced queuing concept is there, Oracle Stream is integrated. Both are integrated. Okay, means the publish of the PubSub model as well as the message queuing is integrated into a single unit in order to avoid the data pooling problem. Oracle Stream Advanced Queuing is OSAQ, if you see, is built on top of the Oracle Stream. Okay, on top of the Oracle Stream. That means you can capture, you can process, you can manage, okay, database events, and leverages the functionality of the Oracle database, so that the message stored can be stored persistently and propagated between queues on different computer and databases and transmitted using Oracle Net Service or HTTPS. So you can see here the data is propagated into various computer systems, and in each and every computer system you may have a local database. So you have to ensure that whatever messages you are communicating or whatever data you are storing, that should be persistent and consistent also. So you can see as Oracle Stream Advanced Queuing is implemented in database table, all other benefits of high availability, of scalability, or reliability are also applicable to queue data. Okay, and you can see OSAQ supports the recovery if the data is corrupted. Then you can also go for recovery, just like I told you in some class about the checkpointing concept. You can also restart the processing, or you can go for security. So these are the features supported by Oracle Stream Advanced Queuing. Now coming to the third part is our metadata catalog. So this metadata catalog is placed in vital, like whenever you are going for a bookstore, you are asking for a particular book. You have seen that particular shop owner or the bookseller. What he is doing, he is referring to a particular catalog. That's why this catalog plays a vital role in distributed heterogeneous environments such as grid or cloud. It is very much important. Because if the catalog is properly maintained, it is very easy to discover and locate the desired data or services. You can easily locate. Okay, and if you see the metadata, which is nothing but you are saying always data about data, right? Or information about the data is maintained in this format. So you can see the first one is you have to specify the name and location of the data resource. You have to mention the structure of the data. Okay, you have to specify the data items, names, and descriptions under the particular resource, and you have to mention the user information, that is name, address, profiles, and preferences, and basic listing and simple lookup of available services and relating functions and locations. So, like VM template is there, metadata catalog may contain following informations, right? So once you get this following information, what you can do, you can easily discover for a particular service. Earliest metadata catalog, if you see, one of the metadata catalog, very popular one is called as MCAT. MCAT is called as a metadata catalog service. It is a part of our storage resource broker, okay, which has evolved to the I system. Generally, this MCAT developed by the San Diego Supercomputing Center, the research center, right? And which the main aim is to provide an abstraction layer over the heterogeneous storage devices and file system either inside or across the computing centers. Like these supercomputing systems, supercomputing center is providing you the facility that you can access to their storage devices and file systems either inside or across the computing center. Okay, you may remotely access the things or you may go for you will go to the center and you can start working in that system. So if you see this NCAT, how they are maintaining these things, how they are maintaining the things, they are maintaining everything in a hierarchical form. Hierarchical form means a tree-like structure they are maintaining. Now come to another type of catalog, that is MCS, developed by Globus Alliance. They are also maintaining this metadata in the form of a hierarchical system. Right? It is also used in the Globus project, okay, where the hierarchical structure is maintained. Another type of metadata you can see that is called as ARDA, metadata for grid applications, okay, which is there in the official catalog of G-Lite software of the EG project. So if you see, this particular project is an exploratory project to study the metadata requirement for various experimentations. So they are also maintaining in the form of hierarchical structure. Because hierarchical structure is very easy because every time you are eliminating other parts, those who are not, you are not interested for. So the main way they are maintaining the attributes in this ANGA application, that is ARDA metadata for grid application, they are maintaining the key value pair. Okay, everything they are maintaining in the form of the key value pair, so that they can locate whatever the type of information, okay, or in order to each entry, whatever entry you want to make, each entry assigns an individual value to the attributes of its selection. For that, they are maintaining key value pairs. The next part is our semantic web. So you may have heard about the semantic network, right? So there is a semantic web. What semantic web is doing? Semantic web, we want automatic discovery and integration of the things. Like UTD, I told you, they want to define three things. One is description, discovery, and integration. But semantic web wants the same thing, but it wants a automatic process. Okay. It also enables that the machine will automatically discover the things or integrate the things without any requirement of human being, right? So it is adding machine processable semantics to the data. And here you can see that computers can understand. Okay, if you see semantic web, computers can understand such information and process it on behalf of the end user. So end user will not need to do anything. So you have to design a system like semantic webs so that automatically it is going to provide you such information. Whatever the information may be needed or may be provided, that will be done in an automatic process. Okay. The resource description framework (RDF) is the first language which is there for semantic web using XML. The first language is your RDF, that is resource description framework, and they are using your web ontology language, so that you can share the metadata and aid in background knowledge. Okay, so here what you can do, we could be able to query, you can ask a query, or you can filter a thing, or you can integrate or aggregate the metadata, and you can infer more metadata by applying a specific rules and policies. that is the responsibility of RDF. So this is called as a semantic network. Semantic web and semantic network is different. Semantic network says that it is a knowledge representation technique which is integrating various objects and finds the relationship between different objects. Like you can say cat like means cat is a mama, cat is a Tommy, cat is food, right? So like that, there are different objects are there. These objects are integrated using your semantic network. So this OWL, right, which I told you, it is a language which is expressing your RDF, that is resource description framework. Okay, so it defines the top level concept of a service into three sub ontologies. The first ontology is called as a service profile. Service profile is nothing but in order to provide a services to the customer, what you need to do, you have to make advertisement, or you have to see how faster they can locate a particular service. That's why many people are saying you have to give unique keywords. That unique keywords will help the people to assess the service. Second is your service model. Service model focuses on the invocation of the services, compositions of the services, monitoring of the services, and deployment of the services. Similarly, service grounding. Service grounding is mapping the abstract to a concrete specifications. The overall view to a, or you can say generalization to the specializations is done by the service grounding. So you can see here the semantic grid related concept and ontology. So there are three things. One is your semantic web is there, grid is there, web services is there. So if you see this part, if you want to integrate the semantic web with your web services, which we call as a semantic web services, which is called as semantic web services, or if you want to integrate web service with grid, which we call as a grid services, or if you go for semantic web with grid, so we are saying semantic for the grid. So we are integrating three concepts here: semantic web, grid, and web services. So like this, you can see here, there is a OGSA, that is we already studied Open Grid Service Architecture. So with respect to the semantic concept, there is a SOGSA, which is a reference architecture for semantic based grids. And SOGSA is extending your OGSA such that many more other functionalities can be supported by SOGSA. One of the such functionality you can see explicit handling of semantics. Okay, or you can define the associated knowledges, or you can provision the services like creation, storage, update, removal, analysis of different forms of knowledge and metadata is supported by your semantic OGSA, which is not supported by your OGSA. Okay, and SOGSA consists of three components. One is your model. So model establishes the relationships. Capabilities. Capabilities shows that what are the responsibilities given to each and every component, and what are the service, which service is dealing with which component. Third one is a mechanism, where elements that will that is going to provide you the delivery, right? So this is the semantic grid architecture. You can see in the top level you have applications, and in the bottom level you have a fabric layer, and you can access these things through the portals, or where the data mining, text mining, collaborative, these are the knowledge grids are there. In the next level, you have knowledge services, which may be knowledge-based data computation service or knowledge-based information service, which is handled by OGSA. And information services, computational services, data is handled by OGSA-based grid services. Next is your distributed job execution management, consists of two basic components. One is your job execution engine. Job execution engine applies a particular scheduling algorithm so that a job can be allocated to a particular resource. It is going to define the resources. Okay, it is going to describe the specification of the resources so that a job can be assigned based on the requirement of job as well as the resource requirement. It can be located to a particular resource, and it is also responsible for your fault tolerance. Another component in the distributed job management is your distributed data management system. which provide the abstraction for the job to access the distributed data. So whenever you are located to a particular resource, it may happen that you have to locate that resource and you have to ensure that all the data associated with that job need to be present in the resource side so that the resource can execute it. So if you see example of such job execution environment, the first one is called as a MapReduce. Okay, which uses generally takes large data. There is a master node, there are a set of worker nodes. By the help of that, it is executing and it is forming the key value pair. Another example is called as Microsoft Drive. So it is representing the job in the form of a directed acyclic graph so that the precedence constraints you can maintain. It also supports the data flowing along various links from one job's output to another job's input in a manner that's similar to the Unix 5 system. If you remember, Unix 5 system also we are doing that. The last one is for this location aware request distribution algorithm is required. Location, what is the purpose of going for this particular algorithm? The name suggests is that based upon the location, like I told you in some class also, if a resource is you want to deploy a customer's application in a particular region in the cloud, you have to ensure that there should not be any conflict with respect to the security or legislation, okay, or laws or enforcement, whatever is there, that should not create conflict. So in order to avoid that one, what happens whenever we are deploying a particular application, then automatically there is a while you are deploying the application, the cloud service provider is asking you choose a particular location where you want to deploy a particular where you want to deploy your applications. So for this you require this location aware request distribution algorithm. And here we are dealing with various data. Like I told you, there is a popular middleware which is dealing with this job scheduling that is called as Panda. Okay, they are dealing with the structured data or semi-structured data. Our objective is to get the semi-structured and structured data from the unstructured data, so that you can do a meaningful analysis using the data. And it is also, you can see these jobs can be handled if the jobs may be a computational job or it may be a data intensive job where data is given more important in the computation because very large data is there. Computational, you are focusing on how faster you can execute the things. So one of the example you can see here, Astrolab is used in the Amazon, which is monitoring the state of a collection of the distributed resources. And if you want to know that which resources is available, okay, out of all the available resources, and which resource is having the minimum load, you can write a SQL query that is nothing but select min load as load, so that it will list the resources which is having less load. It is also using the gossip protocol where one agent can interact with another agent. One agent can talk to another agent and one agent can exchange the message with another agent through this gossip protocol. And it also raises the consistency issues, and the solution is to go for eventual consistency. Okay, consistency means if your AGT is having the distributed resources, if multiple resources are working for the same application, then consistent issue will be